intensity and ask a couple of questions, and the panelists know the questions that I wanted to ask. And the first question is sort of hopefully an easy one, and this is, I would like to ask each one of you, what is the most significant contribution that you think the Top 500 has made to the HPC world? And we'll start with you, Tom, at the far left from my side.
When I heard about that question, there were two keywords lighting in my mind. One is, I think it's the propagation, and another is the promotion. I think the Top 500 list let the public know and understand what HPC is and what HPC could use to do. And also let the medium to help us to propagate HPC concept to the broader area. And another thing is, if we look at the Top 500 list, it's not only the rank of the supercomputers, it also could show the key technologies, including the CPU architecture and the interconnect network and the I/O system, etc. So it helps us to help the vendor and users to understand the trend of HPC technology development and promote the HPC technologies used to the system and application.
Yeah, I would agree. I think for me, the single biggest, and I've attended since the beginning, I think, of this thing, is keeping government funders' attention on HPC. I'd say is the biggest thing, that the contribution it's made over time, and I think that really helped get the HPC community through the doldrums, the economic doldrums of the post-Cold War era, when there was a big dip, people worried about the continuation of supercomputing much more easily. And I also think that today the exascale race would be, without the Top 500, the exascale race would be 3 or 4 years further in the future.
Thanks, Steve.
I think, switch the mic here. Yeah, I fully agree. The single most contribution is really the attention that Top 500 brings to HPC. HPC is scientific computing, and it's amazing the amount of political attention we see around the world to this problem. I think science can be very happy with this, and from that point of view, I hope the attention will continue in the future.
Well, everybody likes a horse race, and so that was on my list as well, the publicity aspect. But I'll say that I think the #1 contribution has just been the historical record. Nobody thinks that LINPACK is the quote-unquote right metric to judge the performance of a machine on real workloads, but it's not bad, and I think the genius was in the simplicity of the benchmark, which meant that pretty much everybody could run it. And we've now got this incredible wealth of 25 years worth of historical data about our industry. We can see trends in processors, we can see trends in countries and interconnects and vendors, all these different ways of analyzing the data. And we've seen the three of you give all these talks over the years, and it's just great. There's so many different ways you can parse the data, and so each list gives us about 2 orders of magnitude of the top part of our industry. So you're not just looking at supercomputing and high-end supercomputing, you're kind of looking at the whole HPC industry, and I think that part's been really invaluable.
Okay, so this was the warm-up. I tried all of you to be very generous and say nice things about the Top 500. So now let's turn this around and say, what is it that you don't like? What would you change? What would you do different? What should be done? So you all look expectantly. Maybe you, Tom, I'll let you go first. Any recommendations, improvements?
Yeah, I think the performance for the supercomputer will be an internal topic. So, because people always ask how faster, they consider and care about how faster the supercomputer could run and how higher performance it could be reached. But I think the measurement methods could be changed if needed. If you look at the past 20 years or more than 20 years, at that time, the computational power, it's maybe the bottleneck of the whole system application. So the HPL, I think it's a good benchmark at that time, and also in the recent 20 years. But now, we all noted that maybe the data accessing ability become the bottleneck of the system and application. So we obviously need some new benchmarks to measure that part. So I think that will be something we need to change.
Steve?
Yeah, I mean, top 500, as Steve was saying, great as a census of developments affecting large supercomputers over time, but it's often been, interpreted, and it was never intended to be a predictor of performance on a broad spectrum of HPC code. So I would have said before I came here today that one thing, and I've said it in the past, one thing that would be valuable is kind of a warning like on a cigarette label that says this could be fatal if you use it as a predictor and so forth. But I was very, very pleased to see the attention paid to HPCG and the Green 500 and the inclusion of those lists. And so my only recommendation would be to give those equal promotional strength. Thanks.
Yeah, I think here I don't fully agree or have quite a different opinion. You asked the question a bit different, the relevance today, and the relevance is clearly from a political point of view and funding point of view. From an application performance point of view, the story is very different, and as we all know. And I think we need, and it even comes to the point where top 500 may actually be a distraction if you have certain goals on the application side. And let me give you an example. If you take the systems that were discussed, there is the Taihu Light system in Wuxi and the Pitt-Stein system that I have a lot of authority over. When you look at the flops per second, there is a factor 5 difference. So Pitt-Stein is a factor 5 weaker in performance. When you look at how a benchmark from the weather and climate community performs, there is this baroclinic instability test, then the order is reversed and the performance is about 2 to 3 times faster. So you can have a factor 10 discrepancy. And we've been thinking about this quite a bit, because the question is what you do to change the metric. And it turns out ECMWF, by the way, has a much more interesting data set that goes back to the 70s, looking again at their model performance. And it turns out that floating point operations per second is not a good metric to design system against. It may be good to look back retroactively, but not looking into the future. And the conclusion we have, and we've been looking at this in a paper that I heard last night was accepted, is we need a metric that relates to a scientific goal. So simulated years per day for a size of for a given size of problem. And the size of problem is very important that this factors in. Remember, in top 500, in HPL, we can tune the size of the problem to maximize this metric of flops. We can do the same for HPCG. It turns out from an engineering point of view, this is not good. You're not going to change your target. If you're paid to do something, you're not going to change your target just to maximize some number, okay? That's a really bad idea. And the third point, so we need to set goals. Like in weather and climate, I think they have very clear goals that everybody can relate to. And I wish that the scientific community could come together behind a few goals rather than everybody wanting their own code to be somehow the metric. And The second one is not just some performance metric, but the size of the problem needs to be set and can be varied over time. But we need to compare apples to apples and not apples to oranges. And the third point, and that is really missing in Top 500, is the algorithmic or the method side. Methods, changing algorithms in the computation, in the history of computing is just as important as changing architectures. And we somehow need to allow that to be factored in. So those are my 3 recommendations that we look at when we go forward.
Thank you, Thomas. Steve?
Yeah, I mean, from a scientific perspective, I couldn't agree with you more. From a practical perspective, I can't agree with you at all. and that is, I would love to see simulated years per day as a much more interesting and useful metric, but there's no way that you could do that, right? And you can't really change the metric that the list uses because then it sort of invalidates that historical record aspect. So we have to count on people that are actually doing procurements and fielding these big systems to be sophisticated, people that understand what's really important and that LINPACK is not that thing. And I absolutely think that the Top 500, despite all the good that it's done, has caused some bad behavior, right? People have made decisions to get a higher ranking on that list. And then there have been other people that said, I'm going to buy a supercomputer and I'm not even going to put it on the list because I don't endorse the metric. I think the reality is that you're not going to be able to change the Top 500 benchmark. I like the idea of augmenting it with some things, and there have been some attempts with HBCG and the HBCC benchmarks and that sort of thing. So we could augment it. I don't think we can change it. I think that it is becoming more and more, the HPL performance is becoming more and more disjointed from real application performance as we move forward, and memory bandwidth and interconnect and other things matter a lot more, and architectural aspects matter. As we get closer to the end of the CMOS era, and we may change the way we do computing or go to completely different architectures, it may become even more stretched to the point where we kind of have to do something. But in the meantime, I'm not sure that there's a whole lot we can do other than sort of continue on the current path.
Yeah, I was going to come to your point, Steve, in a minute on the maybe have to change it because of the trends in computing, but I wanted to sort of ask a more personal question, and this is sort of, you can volunteer here to speak up. Do you have any interesting stories of your personal career, how you were intertwined with the Top 500? Politicians calling you in an office and saying, how come you're not #1, or things like that? It has happened, I was told.
I myself have stayed on the Top 500 world stage for more than 10 times, exactly 6 times for #1 and then 4 times for #2. Yeah, it's. I think I appreciate about that this experience. I think it's. It do impact some of my career or my personal development. I think it's an important thing is the #1 system leading me to connect with the international HPC community. And I and my team, the Tianhe team, and the Chinese scholars could have a chance to exchange ideas and technologies with the people all over the world and broaden my view. Another thing I think also leading me change a little bit of my personal research priority and direction. What can I say that it's come from the transfer from the system-centric to the application-centric. Because, before the Tianhe 1 and Tianhe 2 become the #1, I have involved in the system design work for the Chinese supercomputer for more than 15 years. At that time, I'm focused on to design and implement the high-performance system software, the communication library, the MPI, the job scheduler, and the file system, etc. At that time, I also help people to optimize the applications. But I do that, I try to demonstrate how powerful our system is. And after we become the #1 and got more attention about the system, and the people also consider and care about how the Tianhe-2 system used. What can the support scientists or the society to do the broader application? So it made me change my view to think about that, how if we have some application requirements come from not only the conventional HPC era, also come from life science, smart city, the new emerging applications. So I try to establish some new domain-specific application platform to support our end users, not just to think about our system, but think about our user application. Yeah.
Thank you.
Yeah,
So I gotta ask you to be very short, 30 seconds or 45 seconds, let's say. Everybody.
It'll be short.
It'll be short.
Just as a follow-on to what we were talking about before, I wanted to say that even as the top 500 kind of keeps the government coffers pouring money into this industry, and important for that reason, I think it's also a very good development that a lot of the big initiatives like ECP in the US, Euro HPC, and initiatives in Asia too, are making the internal metric performance gains on their own applications.
Very good.
Well, I've been thinking it's a hard question to answer. The agency that funds us, the ETH board, is putting really all the relevance on the internal metric on certain applications. And so in that sense, the top 500 can become a bit annoying because we have a clear goal that we have to deliver, say, systems for Meteor Swiss with set performance. And then people ask me, why is this not on top 500? Or what is the top 500 performance going to be of your next system? And this is what I mean by a distraction. Yes. And it can be a real problem. So I'm sorry I can't give you a more positive answer.
Well understood. In the good and the bad way.
And I'm kind of in the same camp as Thomas. I mean, we try to spend all of our time focusing on sustained application performance and working with people like Thomas to make machines do useful things. And Top 500 is it's always there kind of in the background about, where will you be in the rankings. And it can be fun when you happen to have a machine that shows up and you can do. But the reality is that we mostly concentrate on applications.
Okay.
It has been kind of nice because my career kind of started with the T3E back in, that we started working on in 92, 93, right at the beginning of the list. So it's been kind of documenting that period of time. So it's been kind of fun for me personally to see that progress.
Okay, so I promised two things, finishing quickly, but also, if we have time, to ask you a real challenging question. So I want you, if you have the answer to the question, just say the answer and maybe 2 words about why you came up with this answer, but no long explanation. So in 25 years, in another 25 years, which is, I believe, 2043 or maybe 2042 if you go back, what do you think the #1 system of the top 500 list will perform?
2 words. One is Zota, I think Zota flops, and another is maybe another quantum computing system.
Okay. Single-digit zetaflop.
I think it will not exist anymore.
I was hoping somebody would say that.
In its current form, and we see some of this already today. Many applications run much better at lower precision, and didn't UJAC show that even the dense linear algebra problem of HPL can be solved more efficiently in mixed precision with tensor flops? So either we change the rules and then your historic record goes out of the window, or it just doesn't pay anymore to worry about top 500.
Yeah, I don't know if we're going to get a CMOS replacement or not. If we don't, I think we'll be at kind of 10 exaflops, and if we do, I'll say 10 zettaflops, just, not quite the same 6 orders of magnitude we've had in the past. But yeah, 25 years from now, we could finally maybe have a quantum computer that was useful as well. So, it could be a different landscape.
And who will be at ISC 42? Okay, well, I think the comments were really insightful, both looking back and looking in the future, and hopefully give you a lot of stimulation to have continued conversation amongst yourself and with the panelists going large. Thank you for joining us.